Okay, this is where we left off on the last podcast. So now we have our third podcast for problem number 12. So we have a trilogy now. What we were trying to do is find out where this derivative, the 4x cubed minus 4 over 2 square root of x to the fourth minus 4x plus 17 over 4 is equal to 0, or possibly where it's undefined. You're just going to have to take my word for it. We could do the work to find where this becomes division by 0, but the answer that we're looking for really comes from the setting the numerator equal to 0. So to solve this problem where we're at right now, let me get my pen to work here. You're just going to set the numerator equal to 0 and solve. So 0 equals 4x cubed minus 4. We'd add 4 to both sides to get 4 equals 4x cubed. Divide both sides by 4 and get 1 equals x cubed. And take the cubed root of both sides, the cubed root of 1 is in fact 1. Telling us that this is a critical point, and at that critical point we could have a maximum or minimum for this function. Since we're trying to minimize the distance, this is the value which would minimize that total distance between the point 2, 1/2 and the function f of x equals x squared. Since they asked us to find the point on the function that minimizes that distance, recall the function was f of x equals x squared. So if I put 1 in for the x value, I get 1 for f of x, or 1 for my y value. So the point on that parabola that minimizes the distance between 2, 1/2 and the parabola itself would be the point 1, 1. Just take my word for it that that's a solution. I don't want to waste any more time with a podcast. We should technically set this denominator equal to 0 and solve that also to find a critical value, but that's not the critical value we're looking for in this case. In this case, x equals 1 is. That's the answer. You have the assignments in your syllabus. There's quite a few problems on optimization. This is a very important unit, and since it's important, since it's difficult, you can kind of expect there'll probably be, I don't know, a couple problems at least on the test, maybe 6, 7, 8, 10, who knows. But these are real important problems. I know the struggle that most students have is setting up that primary equation, and then once they have that primary equation, find that secondary equation to substitute in and solve. So make sure you're working together, helping each other out, getting those equations set up. And once you get the equation set up, it's just basically finding your relative minimum or maximum points like we've done the last few sections. Find the derivative, set it equal to 0, find your critical points, and that's typically where your optimization will occur. So if you do have questions, I'll be back tomorrow to help answer them. Try to get as many of these problems set up with the equation, and we'll go through a little bit more tomorrow. So good luck.